السلام عليكم دكتور أحمد. السلام عليكم دكتور أحمد.
وعليكم السلام ورحمة الله. أهلا مرحبا أختي نوال.
Okay, doctor. I think it's okay now. We can start. It's 11. Let's see if the first presenter are here. Muhammad Mahmoud. Okay. Okay, doctor.
Okay. بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على سيدنا رسول الله وعلى آله وصحبه ومن والاه. I'd like to welcome all of you to this session. This is session S1-A, which is dedicated to machine learning and big data analytics. We have 5 presentations. We will start with the first one, entitled Deceptive Phishing Detection and Prediction in Social Networking Sites Using Data Mining and Ontology, and it will be presented by Mr. Muhammad Mahmoud Ali from Osmania and Muwaffaqam Jam College. Hopefully I pronounce it correctly. I'd like to remind the presenters to stick to the time. You have about 15 minutes for presentation and a few minutes for question and answers, and as well as discussion, and should not by any means should not exceed 20 minutes. Also, please introduce yourself at the beginning of your presentation in a couple of statements. So without any further ado, please, Mr. Muhammad, share your screen and start your presentation.
Assalamu alaikum wa rahmatullahi wa barakatuh. Myself, Dr. Muhammad Mahmoud Ali. I would like to give my presentation on this. My screen is visible? Hello?
Yes, it's visible.
The topic of my research area is about data mining and ontology. So we have worked on deceptive phishing detection from social networking sites. For this, we have used 2 techniques. One is data mining and ontology. So come to the major problem with the phishing is, so many people leak out their personal information through social networking sites like WhatsApp or Facebook or LinkedIn, so that phishers may mimic the users to get their confidential information, such as banking information or their personal account information. For example, I am a user, and a hacker may pretend as if you are friend that myself, I would like to deposit some money to your account. So can you give me your account number so that I can deposit some money, just because I'm happy with you. So this sequence of things will happen between the period of days or weeks or months. So this goes on. So due to this, so many of the people leak their personal information. So usually mobile number is open to anyone, so anyone can contact. Similarly, the email, their Facebook account is open to anyone. So they try to make friendship with the users and try to get their confidential information. To overcome this basic problem, so we tried to implement a phishing detection system. That is, an algorithm is developed by using ontology also, so that whenever such type of phishing words are sent by the users, so those users are identified and tracked, so that the confidential information is not leaked. So this is an image which shows various places of phishing is seen through mobile and through email account or through WhatsApp messaging application, which is at the right hand side of this figure is given over there. So whenever such privacy information is sent by any user or any name user, so that information has to be identified. So this is our main aim. So that if we trace such type of words, so the system should generate an alert system or alarming system to the user that so your information is leaking out, so that he can take some necessary steps, and he will try to avoid that sending future messages. So to do this, we have designed this system. The architecture of our system is shown over here. The like instant messaging system. It is a simple messaging system is developed. So to and at the same time, so we have used different types of databases, which is integrated with the WordNet ontology. As I have in beginning said that we have used ontology as well as data mining techniques. So by using some predefined rules, so the system will capture the such messages. So to initiate all these things, at the right hand side, APD algorithm is mentioned over at the right hand side of this diagram architecture. So that program try to initiate the task to surveillance the messages and capture the suspicious phishing words that have been sent by the users or received sent by the hackers. So the flow chart of this diagram is depicted over here. Like phishing rules, already I have said that we have used some kind of phishing rules, so which are given in this table. So different types of accounts, like for example, a table shows a phishing words related to different types of domains. We have taken only few important words, like left hand side here, type of threat like financial gain, payment notary, and identity access, deceitful elicitation, account creation tip, URL related. So let us say discuss about financial gain. Related to financial gain, the phishing words that are used in messaging applications are account number, bankers, credit card details, date of birth, name. For example, I am the fisher will try to make friendship. Like what is your date of birth? What is your sign? When did you born? So in the so and so month, so and so era. So in this way, they try to make friendship. Then later on, they mimic as if I am your friend. So I am very happy with you. I am very rich person. I would like to transfer some amount to your account. Can you give me your account? Definitely, if someone will ask for free of cost for depositing some money after a series of this type of situation is created after series of weeks or days or months. So in between, so daily they will not ask in first instance, only after making friendship. After certain period of time, they will do such kind of things. So in that case, you may be people will leak out their privacy information like account number. So in that case, too, we want to alert the users that you should not leak out such type of information. So this is the way we have a plan. So these are the very confidential one. And very interestingly, account number is not only a single one. So related to this account number, there are many number of words. So like he may ask what is your bank number, or he may ask what is your account. So to make different types of synonyms related to one specific account number, so we may use some ontology. So that ontology considers it is a lexical ontology, the lexical database which maintains different types of synonyms of a single word. So that is the reason that not only if account number is detected, it may be account or account number or bank number or what if we will detect identify different types of words. So if DOB is written for it. Usually when someone asks DOB, send a message like DOB may be date of birth, so it is written in short form. The system should intelligently identify that DOB is nothing but date of birth. So some people will ask, what is your date of birth? Full, or what is your birth or date? So such type of words are used by the fisher. So those words are identified by this particular algorithm, that is APD algorithm. So the architecture which I have shown here, so the flow chart how it works here. And again, I am going back and showing that. So first, it will filter out unnecessary words and detect words based on the phishing rules at the top. Beside the start, phishing rules are there, and I have shown all the rules that have been given in the table. So those rules are mapped to these words after filtering the messages from the users, and it will check that if any words are mapped. If it is mapped, then it will intelligently store in the knowledge database. Then after storing, then it will try to trace the person who emailed, who has messaged you. So their phone number. So usually many of the phone numbers are linked to their mail IDs. So in that case, the system will intelligently try to identify their email ID and check their profile details by and profile details of those hackers. Then it will store from different databases like EDB, email database is maintained. Then it will try to identify the ISP provider from which that hacker sent that message. So every gateway IP address of the those culprits who done, then it will try to report to the crime department that so and so person, so and so hacker is trying to take some private or confidential information of particular person. So then this is an act under FISA Act. It is a criminal that someone without knowing or unknowingly take out some privacy information from others. It may be online users or personal users, any kind of users. So this is under FISA Act. It is a crime. So in that case, a case of proceedings will be initiated through proper channel as per the FISA Act. So the algorithmic steps are given over here. What the it does is again thoroughly explained. I'm skipping this slide due to time constraints. So at the back end, so information theory principle is used. Kullberg labeler divergence rules to check the probability of that which of the word is mapped to the which kind of domain. So different types of domains I have shown here. Like here also see for financial gain password maybe belongs to fame and notary also, and financial gain also password may be there. Like bank account number. Whenever I want to log in, I may enter username as well as password. So few words map there and here. So but among them, whatever majority of words to which domain it is mapped, it is checked by this particular entropy. And next, and the similarity among that is also identified by using tree alignment algorithm, which is discussed in the next slides. So see here, this is the algorithm which tries to greater similarity hierarchy learning algorithm. It try different types of WhatsApp messages are sent by different users. So, but here under how many number of words are sent by particular users are mapped and stored, and similar and the same word may belongs to different domains. In that content also, it will just go on saving. So based on the threshold value THS, which can be given by the APD inside the APD algorithm, we can set if it is greater than 40% or 35% or 80%. If we go on giving the a specific threshold value in our context, we have taken 35% and checked, and we could able to get some set of words which with different domains. So which type of crime he was trying to get. So then this is our BI model, ontology-based information extraction model for root word extraction. So very interesting diagram. Directly, I'm going to, and this is again tree alignment algorithm. Adjust all those words under which domain it belongs successfully and allocate to that specific domain. This is done by tree alignment algorithm, and this is what I want to show that. So these are the different words. So at the figure 6, at the here figure 6 near to this ellipse. In the ellipse, I have different types of words like account, banker, credit card, name, mobile number, data. These are the words, set of words which has been which has been messaged by the users, and that is just it is stored in the KDB database, knowledge based database. Next, ultimately, and when it maps to that, and this maps these words. So here, here you can see that account is written at the in this ellipse box, and but in the my database as a set of phishing words, financial gain under account number is there. Number is extra word. So that system should intelligently identify that account number is has to be mapped with that account number. So similarly, phone number is written, but it is actually mapped with the mobile number. So who plays this role? This is the important role is played by the ontology. So ontology, and one more important feature of this ontology lexical database is that it also has some editor features where some spelling mistakes are made by the user. So those words are also corrected. And similarly, credit card. So ultimately, this diagram depicts that at the back end how the system works under one specific thing, and ultimately this will be here at the top root node at the left hand side TPDB it is written. So ultimately it says that this is the type of crime, financial gain. Similarly, different types of crimes, deceitful or identity access, different types of crimes can be identified by you. So for this, we need to have, so we don't have official access to the WhatsApp application. So what we did is we have developed this application in our college and tested with different types of students in the lab, which have 24 systems, and we have tested it, and we could able to prove that we could able to detect. So again, it depends upon the type of threshold value which we have assigned. So, and this is the overall algorithm. Again, we have drawn like GSHL algorithm is one which performs the greater similarity hierarchy learning algorithm, realignment algorithm we have used. So these two algorithms are called, and this is the final algorithm where we call those algorithms to perform all these tasks. We have written an algorithm for this also. So ultimately, I also said that who performed this task, so their email ID is identified. Phishing word belongs to whom? In this email ID. Who? What is the name? Email ID has person name. What is his? Again, after going in depth, that person. Whenever you register for your WhatsApp, few information like mobile number is mandatory. If the company gives the access, so age is also identified based on their birth date and their place. And most of the people when making Facebook account, they will enter their where did they do their schooling, their college, and all this information. So once email ID is identified, their personal details can also be identified by different by using RD algorithm, relational database wrapper algorithm that is used. So we have that was the algorithm which was developed by someone else. We have used that algorithm to trace that and through by writing an API, so that RD wrapper will go through that and try to identify based on the mail ID. It trace the different types of information from the web, and even their IP address and their place, and ultimately that email ID consists of crime threat activity type is identified and reported to the crime department. This is the what we have done. So we have tested for.
Mr. Muhammad, can you please conclude?
Yes, sir.
Can you please conclude your presentation?
Yeah. I'm concluding. Ultimately, so, sir, this is the final chart with different domains we have discussed and drawn the diagram with very good effort. And so the whole in yellow color mark as account creation tips, deceitful elicitation, URL related, financial gain, identity access, PN. So these are the root words. How, sir, the earlier diagram was just depicting only financial gain. This is the overall diagram at the back end, how the performance is done. So this is, and many of the messaging applications are not monitored or surveillance to identify such type of phishing crimes. So we have compared, and this is an extremely PhD work where we try to say that we have developed this our system and tested. As I have said that relational to the data wrapper we have used to identify different types of information like location mapping based on ISP and IP address. So this is important thing that many of the people they did not do. We did this. So ultimately, I can conclude that framework is developed that helps e-crime department to trace and identify culprits from cyberspace. So we have used ontology, and currently many IMS instant messaging systems lack to trace phishing messages dynamically. Even children's sometimes small children's will take up their father's or brother's phone, and sometimes they may chat with their friends, and in that case they may leak out their personal information also. Has been reported in many of the newspapers, and experiments conducted on dataset proved to be better. So terrorists and other cyber crimes can be also traced if we consider this concept and inculcate into the suspicious messaging applications to identify the criminal activities by terrorists or some unidentified persons. So this can be done by, if the table is converted to with some suspicious words, we can able to trace that also. This is our main conclusion which we can able to say. So, what is our main issues and challenges is we are working to do identify some type of phishing words in specifically in multilingual languages or Roman language like Arabic, Telugu, English, Marathi, Hindi, different types of language. We are trying to work out that can be detected from those languages also. So, so with this, I would like to stop
Okay,
the.
thank you, Mr. Muhammad.
Yes, sir.
Thank you very much for your presentation. Is there any question from the floor or comments? I have one question, Mr. Muhammad. I did not go through the details of your paper, but I have noticed that in the experimental results, you found your system found 4 words successfully out of 6. What was the size of your data of your test set?
Yeah, test set, sir. We have collected these words through brainstorming sessions. As I have told, we have conducted in our lab because WhatsApp messaging application messages are not, we cannot take that. So these are personal. So we need to take permission from the main people. So we have developed our own messages.
I mean, what I mean, Mr. Muhammad, what I mean is, do you think 6 words would be sufficient for testing such approach?
Yes, sir.
Is 4 out of 6 is considered as good enough for to prove that your model is working properly?
Yes, sir. Sir, the test set we have tested is for 1,000 to 1139 messages. Also, we have tested in financial domain.
But I did not see this in the figures that you have presented. Only the one you mentioned is 4 out of 6. Anyway, thank you very much for your good presentation.
Thanks a lot.
And wish you all the best.
Thank you.
Yeah. Thank you very much. We'll move now to the second presentation by Mr. Yana or Miss Yana Bondarenko.
Miss.
Miss, yeah, I'm sorry. Data-driven, the paper entitled Data-Driven Decision Making Based on Revenue. Please share your screen. Can you stop sharing, Mr. Muhammad? And may I ask Miss Yana to share her screen? Unmute yourself, please.
Good morning. I'm pleased to be here. Have you seen my slides?
Yes, it's visible. Please introduce yourself, your organization or your university, and go ahead.
Thank you. My name is Yana. I have been working on position of associate professor at Dnipro National University in Ukraine. Today, I would like to tell about data-driven decision-making based on revenue. The culture of experimentation implemented by successful big data companies allows for data-driven decision-making, the creation of valuable products and services, attracting new and retaining existing clients, and increasing profits. The culture of experimentation has become a common practice in innovative companies. Airbnb, Amazon, Booking, Facebook, LinkedIn, Microsoft, Netflix, PayPal, Spotify, Uber, and numerous others have been developed experimentation platforms specifically for conducting online experiments. The culture of testing as many ideas as possible, as quickly as possible, encourages companies to swiftly test and iterate. Companies can quickly adapt to changing conditions, optimize processes, and enhance their products and services. The simplest online experiment with two groups of users is called A/B testing. It's optimization method that attracts users via online advertising, search engines, emailing. Consider the flow of the users. Each user can be selected to join either the content A or the content B, with probability 1/2. The content A located on the control page and content B located on the treatment page should be the same for one item whose impact needs to be tested. The user's activity inside the page is completely defined by two events: success and failure. Success is purchase. Failure is no purchase. Revenue metrics such as purchase probability, average revenue per sale, average revenue per users are considered. The aim of presented research is to propose analytical solutions for revenue metrics in order to answer for several questions. First question: what is the probability that the purchase probability for user group interacting with content B is greater than that for the user group interacting with content A? Second question: what is the probability that the average revenue per sale for user group interacting with content B is greater than that for the user group interacting with content A? And third one: what is the probability that the average revenue per user for user group interacting with content B is greater than that for the user group interacting with content A? To answer these questions, the Bayesian data analysis is leveraged. Let us consider the scheme for implementing Bayesian estimation for known parameters as shown in the figure. Planning an experiment without prior information about the statistical properties of random variables is quite rare. The theory of Bayesian estimation allows the combination of prior information with experimental results. The prior information is given by the prior distribution of the parameter vector. The empirical information is given by the experimental results and provided by the likelihood function. The posterior distribution contains both prior and empirical information united by Bayes' theorem. The loss function defines the error when replacing the value of parameter with its estimate. The Bayesian point estimates are taken as the points where the posterior risk function reaches its minimum value. The Bayesian credible interval is constructed using the posterior distribution. Several assumptions serve as conditions that must be satisfied before drawing inference. First assumption: the beta distribution is a popular model for modeling the uncertainty associated with proportions, so the purchase probability follows a beta distribution. Second assumption: the inverse gamma distribution is leveraged for modeling the average revenue per sale. Detailed explanation is provided in the following slides. And third assumption, the purchase probability and average revenue per sale are independent random variables. Let us consider the support of the second assumption. Our aim is to test the statistical hypothesis about the inverse gamma distribution 1 of the expected value of purchase amount. The solutions of the system of equation 2 and 3 are estimates of maximum likelihood method. Pearson's chi-square goodness of fit test is utilized for null hypothesis testing. The test statistic is equal to 4. The null hypothesis is rejected if inequality is true and accepted otherwise. The data of writing supplies were taken from one of the largest online stores in Ukraine. The data consisted of samples of prices for different types of pens and pencils. Results of testing null hypothesis are shown in the table 1. Sample sizes, parameters estimates, chi-square statistic, critical value, and decision. The null hypothesis is accepted, so the observed data is consistent with the null hypothesis. Figure 3 and 4 illustrate the sampling distribution histograms of the average revenue per sale from the sale of colored pencils and children's pens. The solid red lines represent the probability density function with estimated parameters. High p-values indicate weak evidence against the null hypothesis. In other words, the observed data is consistent with the null hypothesis. Let us consider the distribution of purchase probability. The number of purchases in one trial follows a Bernoulli distribution 5 with parameter lambda, which is called the purchase probability. The likelihood function as a function of lambda is equal to 6. The beta distribution is leveraged as a conjugate prior for likelihood function 6. According to Bayes' theorem, the posterior distribution of the purchase probability is equal to 8, where hyperparameters can be interpreted as follows. Alpha is the number of purchases made by n users, while beta is the number of non-purchases by n users. The probability, the purchase probability for group interacting with content B is greater than that for the group interacting with content A is computed by 9. Understanding which content drives higher purchase probability allows product managers to focus on what works best. By knowing which content performs better, manager can allocate resources more efficiently. This includes budget, time, and effort towards creating and promoting the more effective content. Animation 5 illustrates the prior and posterior distribution of the purchase probability for content A and content B respectively. The probability of interest is computed continuously during experiment and indicated in the figure title. The goal is to increase revenue. Knowing which content boosts purchase probability helps in driving sales and revenue growth. Let us consider the average revenue per sale. Suppose that purchase amount follows exponential distribution 10 with rate parameter theta, where the reciprocal is called the average revenue per sale. The likelihood function as a function of theta is equal to 11. The gamma distribution 12 is leveraged as a conjugate prior for likelihood function 11. According to Bayes' theorem, the posterior distribution of the theta is equal to 13, where hyperparameters can be interpreted as follows. Alpha is the number of complete purchases made by n users, while beta is the total amount of complete purchases. The probability that the average revenue per sale for group interacting with content B is greater than that for group interacting with content A is computed by 14. Knowing which content generates more revenue per sale helps in calculating and maximizing return of investment. Resources can be allocated to produce and promote content that yields better financial results. Animation 6 illustrates the prior and posterior distribution of the average revenue per sale for content A and content B respectively. The probability of interest is computed continuously during experiment and indicated in the figure title. Data of revenue distribution linked to specific content can guide strategic decisions, such as which content to feature more prominently or which marketing campaigns to invest in. Let us consider the average revenue per user. The theorem about the ratio of a beta distributed random variable to a gamma distributed random variable was proved. In particular, the cumulative distribution function and probability density function of ratio were derived analytically. The average revenue per user is equal to purchase probability times the average revenue per sale. The probability that average revenue per user for group interacting with content B is greater than that for group interacting with content A is computed by 9. Knowing which content influences higher average revenue per user helps in accurate revenue forecasting. This can aid in setting realistic financial goals and planning the future growth. Animation 7 illustrates the prior and posterior distribution of the average revenue per user for content A and B respectively. The probability of interest is computed continuously during experiment and indicated in the figure title. Insights from this analysis can inform product development strategy. Features or services associated with higher revenue generating content can be prioritized and expanded. The loss function quantifies the monetary losses incurred due to an incorrect decision regarding content selection for website. The expected losses, the expected value of loss function is equal to 20 when content A is selected and equal 21 when content B is selected. In this paper, the integrals have been computed analytically. Closed-form solution allows for efficient computation when dealing with big data and complex models. Closed-form solution yields exact results and avoids the approximation errors associated with numerical method. The expected value of loss function is compared to the value of acceptable losses after each user's visit to content A or content B. If inequality 24 are true, then online experiment continues. If inequalities 25 are true, then experiment stops and content A is chosen to publish. If inequalities 26 are true, then experiment stops, content B is chosen to publish. Figure 8 and 9 illustrates the behavior of the expected value of the loss function when varying the purchase probability and the average revenue per sale, respectively. In this research paper, analytical solutions for revenue metrics are proposed. These solutions allow product managers and business owners to make data-driven decisions to increase revenue and maximize profitability. I want to thank all reviewers of my paper for their careful reading of the manuscript and their comments and appropriate suggestions about the perspectives of further research. Thank you.
Very much for this very good presentation. I have a question. Mr. Yana. It's clear that the complexity of this approach is a bit high. So how would it be affecting the results in terms of accuracy as well as practicality?
Computational complexity can be a limitation for a proposed model that involves the Mayer-G function. Evaluating in closed solutions the Mayer-G function often requires numerical methods such as hypergeometric series or Mellin-Barnes integrals, which can be computationally intensive. These computations can consume a lot of memory and processing power, making them less feasible for large-scale application or systems with limited resources. The time required to compute the Mayer-G function accurately can be substantial, which is a drawback for real-time applications. Maintaining numerical precision in complex calculation can be challenging, potentially leading to less accurate results. These factors can limit the practical applicability of analytical models.
Thank you. Thank you very much. Is there any question or comment from the floor? Okay, if no more questions, thank you very much. Kindly stop sharing. Yes, I think there's one question here. Mr. Hassan. Do you have a question, Mr. Hassan? Technical team, can you please unmute him?
Thank you for your presentation. I have just one question. What techniques can be used to improve the numerical stability in these computations?
I have achieved analytical results, and frankly speaking, I didn't investigate this issue yet.
Okay, thank you.
Thank you.
Okay, thank you. Thank you very much. Now I am going to give the session chairing to my colleague, Dr. Orlando. He will chair the rest of the session. Thank you very much. Dr. Orlando.
Thank you, Dr. Ahmed. Still good morning. So our next presentation will be a paper entitled Safeguarding Student Data Privacy, a comparative study of anonymization techniques using the Mondrian algorithm. So I think it's going to be presented by Nur Aini Rahmawati. You have the floor, please.
Wait a minute.
Please share your screen.
Okay. Could you see my presentations?
Yes, it's visible.
Okay, great. Thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning there and good afternoon maybe in Indonesia. So my name is Nur Aini Rahmawati. Me with Muhammad Arik Ramadan will present about the safeguarding student data privacy in comparative study of anonymization technique using the Mondrian algorithm. We are from Department of Information System, Institut Teknologi 10 November, Surabaya, Indonesia. Okay, so what is our motivation? So I would like to introduce first about what is data privacy. So what is important of data privacy? Today we know that a lot of data coming from, and then there is the digital environment. There's a lot of oversharing, and there is a privacy concern that we need to concern about that. So that's why based on of that, and if you need something for your research or for your work, you need to consider how you preserve the data privacy. Okay. So in terms of the legal context, maybe you already known about the GDPR from EU, but right now in Indonesia, we also have our local legal, yeah, with the personal data protection, which already issue on 2020. And then we also focus on, it's similar to the GDPR, we are concerned about the data collection, storage, and disclosure. So in terms of this, there is a lot of a classification of the personal data. For example, the health, criminal records, and general data, some like name, gender, social networks, and so on. Okay, and based on of that, because of that, we already have the Act, Personal Data Protection Act in Indonesia. So we would like how our data can be protected. So this is one of methods. We use the data anonymization technique, which is we try to remove all the personal identified information to protect the privacy. If you want to use your data or you want to share your data for like research purpose, so it's not like for if you want to open your public your data for the fair data or so on. And what is the benefit? You can allow another person to use or reuse your data without compromising with individual privacy. So this for the example, if you have the data that's in contains age, gender, and illness, which is we have the age of each persons in here, we can change to be different format. Let's say this one will be the range for the age from 24 to 30 and 20 to 30 and so on. This is how we want to make it our data anonymized. So anyone cannot identify again after the anonymization, but still the information still not lost. Okay. And then we use the K anonymity. Yeah, what is the K anonymity? So the K in here means that its record is distinguishable from at least K1 other records to prevent the re-identification. So if you choose one or two rows, you could not identify which one of this person that belongs to that data. So how they use that one? They want to make a suppression or generalization. Suppression is mean you remove uh, the identified data, the personal data, and for generalization you make it like categorized, like maybe is you not mention about your city, but you mention about the country and so on. So it makes your data cannot be easy to identify. Okay, and then we also use the L diversity. That means that how we make it the sensitive attribute with iscanimous can be grouped, protecting against the attribute of disclosure. How to do that? We need each group contain at least L different sensitive value. For example, if you have the medical data sets, and then the group might include the multiple disease. Yeah, so in terms of the patient medical record, and then you have to ensure no single condition that dominate and protect the privacy. So that's why this is the how it goes, the algorithms. And then after that, we also use the metrics, yeah, for check all the data set that we produce on. This we call is the closeness to ensure the distribution of the sensitive value of your personal data protection. For example, how is the similar the distribution of the whole data set? How to implement it? We have to control the maximum difference of distribution. So we know that how much the information loss based because of the anonymity. So Okay, so how about the Mondrian algorithm? The Mondrian algorithm is the multi-channel partition approach to the K anonymity, how we recursive divided the data into the group based on the generalization and suppressions. So for that use, we use the data set from the student in ITS in our university, including the gender, age, GPA, and so on. I will give you the idea, the presentation of the table, and then we present the step mention of the step data cleaning dealing with the missing of the consistent value. Yeah. For example, we convert the phone number to the standardized city names to ensure the data uniformity. So this is the our data. For example, we have this data consists of the name of the student. This one is the identifier of the students. This one the social service number in Indonesia, and then this the phone number, this the address, postcode, religion, gender, the blood type, marital status, and GPA. So this is the actually this is the we already actually this is not real data because it's already removed it because we need to protect the privacy. And then this just was the example. Okay, and after that we try to remove the informations, yeah, for especially for the sensitive data. For example, the name, this is the sensitive, and then this one the NRP, this is the Indonesian students information, and then this is the social. We have to remove, or we call it the suppression methods, and also the phone number. But for others, we can make it generalization. For example, the address can be generalized by the name of the city, of the name of the country. I think the city, that's fine in here because we know that most of the student is from Indonesia. So we just make it general for the city and so on. Okay, and here the result. Oops. Okay, we try to make a different scenario for the K and the L, the K anonymity and the L diversity. So K3 and for K3 and L3, we can see that the results we have the frequency of uh the row that coming through. This is this goes going down after that, and then you can see for the K4 K4 and L4 after the partition, after anonymization, and then this for K5 and L5. And here's the closeness between we want to compare between of the K-anonymization and R diversity. As you can see, this one the distribution for K3 and L3 is not much. There is not much information loss in here. So I think this is one is better than other partitions. As you see, this is the result. If we use the the K3 and K3 and L3, as you see in here, the name we make a suppression in here with the wheel card, and then for this one we just use some suppression again, just for some number of digit number of the student, and also for the social service number in Indonesia. We also suppressions one 5 parts, yeah, and then the phone number as well. This one only we use this one, and then after that, this for the address we only use the city of in Indonesia, not all the address, and then for the postcode, and this one for the region, and so on. This is the K3 and L3 result. Yeah. Okay. So based on that our finding, we see that the closely anonymized group mirror the sensitive data distribution, And if you see the NCP normalized central penalty, if you see the T closeness result, that only the NCP for K3 and L3 is around 15%, yeah, for indicate the low data loss. So even we try to make it anonymized, the data still is good, yeah, still only 15.7%. Okay. And so, okay, so based on all that, our first experiment for K3 and L3, so the good balance and the T closeness is around 0.503 and the NCP is 15.7%. But the trade-off, if you have the higher K and L value, increase the privacy, but the result is there is a lot of greater information loss, higher NCP. Yeah. Okay, so the conclusions, as I see that when we use the Mondrian that contains of the K anonymity and R diversity, we can make it some loss of the information if you have the high K and high L. But if you try to use the lowest K and L, it's very useful with the moderate privacy, but the value offer more privacy but reduce the data utility for your research. For the future direction, maybe we need to compare Mondrian with other method for different privacy or maybe different data set and maybe different suppression technique, because in our case we only use the wildcard or some digit removed from the data, and for the impact of maybe different data set like the health or for the financial data and so on. Okay, that's for me. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you very much, Nur, for that presentation. Now we proceed to the Q&A. Is there any question from the group? Anyone from the audience who would like to ask any question? Yes, Hassan. Feel free to unmute
Assalamu
yourself.
alaikum. Yeah, I have one question here. Thank you for your presentation. And my question is what the pre-processing steps that were taken to ensure that the dataset have high quality standards?
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh, Pak Mr. Hassan. So how we for create the data quality, we only the cleaning is only for like if there is any semicolon or so on, because the data is already in our university data sets. So the problem is not in the processing part, but the problem in the suppression or in the suppression and generalization problem. So in that case, we have to make sure all the data, for example, the digit of the student identity number, and then all the things is obey the rule. Yeah, like they say, we have the only 10 digit or 16. We have to make sure that, and also for there's some things different like the address. Yeah, the address. Sometimes they use the we want to remove only for make the generalization only for city, yeah, but the format when they input the data is different each other, so that's why we need to make it pre-processing to make sure how the way that formatting, especially for the address, can be make it the data more good quality. Thank you.
Thank you.
Thank you, Hassan, for the question, and thank you, Nur. Anything else? Any other questions? Yeah, I have one, Nur. You have put in your presentation about the values of K and L in the Mordian method, that if the K and L values are higher, then there's going to be more lost in the utility. So have you identified how much should be the maximum value of K and L to moderate the loss?
Okay, thank you, Dr. Orlando, for the question. That's really good question. So, based on our experience, so we try to only use the K3, 4, and 5. Yeah. So because it is high computation to make it that. So I think that if you see for K4 and 5, especially 5, it makes the quality of the NCP is higher. Yeah, so it's kind of this 80.2% for the K5. But I think that still we can use that, but right now there is no I think there's no paper that mentioned that. I think 50% that's fine. I mean 50% is really high. So for 25, I think it's fine because it based on our experiment. We have for the K3L3 we have 17.7%, and then for K4 we have 17, and then for K6 we have 18.2%. So I think 20 still reliable, but if we more than that, it's difficult if you want to use the data for, like example, for machine learning or data mining, because the goal of this data anonymization you can use for other, you can reuse for another research, for example for data mining, machine learning, or deep learning, or AI, so on. So if you want use the more lost the data, I think the result will be not accurate. Yeah. Is it have answer your questions? Hello? Hello?
Yeah, thank you very much, Noor.
Yeah.
Thank you for the presentation. And I guess there are no more questions. And thank you very much for the response to my question. Now we are ready for the next presentation, which is going to be integrating hybrid systems for robust anomaly. And this is going to be presented by Eunice. I think Eunice is already here. Okay, so the floor is yours, Eunice. Please share your screen.
Is the screen clear? Hello, do you hear me?
Yes, Eunice. Yeah, it was okay. Okay.
So today we are presenting our paper, the title Integrating a Hybrid System for Robust Anomaly Detection in Big Data. The speaker and the correspondent author is myself, Yunus Filari. I am a student, a PhD student in Engineering Science Laboratory in the National School of Applied Science, Ibrahim University in Morocco. So let's begin with our plan. The first section is about an introduction. The second one is the define the problem. The third section is about introduction to our model DT-SVM-NV. The fourth section is about model workflow. And the fourth one, the fifth one is the experimental result. The sixth one is comparative analysis. And the last one is conclusion and future direction. So let's begin with our introduction. Data expanding rapidly across industries, healthcare, finance, cybersecurity, and with the growth, the detection of anomalies in large dataset has become crucial. Anomaly can indicate fraud, system malfunction, and other risks. However, conventional anomaly detection methods struggle with the scale, variety, and velocity of big data. So that's motivate us to develop a new approach which integrate multiple machine learning methods to improve detection and the detection accuracy. So let's talk about the problem definition. The goal to detect data point that specifically deviate from the norm, relieving unusual pattern that may indicate critical issues. In big data environment, traditional method often fall short due to high dimensionality, data imbalance, and real-time processing needs. Our hybrid approach addresses this challenge by combining techniques with the complementary strength. Let's move now to the introduction to our model. GTSVM-ENB is a hybrid anomaly detection model designed specifically for big data. We select the decision tree for feature selection, SVM for high dimensionality space classification, and naive Bayesian classifier for probabilitics evaluation. Together, they create a system that is both accurate and scalable for large data environment. So now let's talk about our model. So in our model, we have three phases. The first one is data is processed and feed into the decision tree for future decision. Then selected feature are classified using support vector machine algorithm, after which the naive Bayesian classifier provide probabilitics classification to finalize the decision. This cascading approach optimizes both efficiency and accuracy. So let's move now to our experiments results. We tested our model on large data sets exactly on the traditional transactional data. Our model achieved an accuracy of 99.94%. This result demonstrates that our model is well suited for identifying anomalies in large scalable complex datasets. So let's move on. The next section is comparative analysis. To understand our model performance, we conducted a comparative analysis across metrics like accuracy, precision, and recall. Our model consistently achieved the highest score, especially in accuracy, making it more reliable to high stakes application. It's make our model a promising choice for environment where the cost of false negatives is high, such the fraud detection. So let's move now to our conclusion. In conclusion, our model offers a robust solution for big data anomaly detection, combine the threat of decision tree and the SVM and naive Bayesian classifier. Our experiment demonstrated superior accuracy. In future, we plan to optimize our model for real-time detection and exploit in applicability in additional domains. And also, we plan to test it in real-time streaming environment for industries like telecommunication, where anomaly detection must happen instantly. Thank you for your attention, and we'll welcome your question.
Thank you very much. We'll now proceed to the Q&A portion. Are there questions from the audience? Hassan, I think you are raising your hand. Go ahead, Hassan.
Okay, thank you for your presentation. The metrics that has been presented indicates high accuracy, precision, recall, and phone score for the proposed model. So could you please provide insights into the datasets, the validation methods, how you can achieve similar result? Thank you.
Thank you. So we validate our model on large scale data set, especially the translation data, which contain real world pattern for anomaly as fraudulent activities. Our data sets varied significantly in structure. It's a structure database which help us demonstrate the model robustness. Is that help you your answer?
You have a follow-up? Do you have any follow-up question, Hassan?
Yeah, were there any challenges during the evaluation of the data set, or if there is any data imbalance within that data set?
Our model is partially effective with high dimensional data due to the decision tree feature selection phase, which reduce demonstrability of before processing by the SVM algorithm. SVM we also found our test scale with the increase in dataset size, maintaining in high accuracy and efficiency.
Any feature selection process before the data going to the model, or?
Can you repeat your question, please?
Did you do any feature selection process?
Yes, using the decision tree, we are using a feature selection for the phase to the because the data set is high. Demonstrably we using the decision tree feature for processing by the SVM algorithm.
Okay, thank you.
Thank you very much, Hassan, for the question. I just have one follow-up question. By the way, you created a hybrid model, and you tried to compare your hybrid model with some other models, and really the accuracy of your model is far away from those models that you have compared with. But I noticed that you did not compare your hybrid model with the two models that you combined. Why did you not try comparing it to SVM and Bayesian alone?
It's just a choice to compare it with this with the other algorithm, not with my algorithm that I use.
No, I mean, but the algorithm you use, you combine already two, SVM and Bayesian. But I would have rather would like to see the result or the comparison when I use SVM alone and I use Bayesian alone as compared to your hybrid model.
I understand. No, I don't do this this etap in my research. I just chose the algorithm who favorites in the I compare it with other algorithm.
Okay, because for me, for example, what if I use SVM alone and it can also yield high accuracy, just like your hybrid, or Bayesian alone? That should have been a very good point of comparison. So, but anyway, thank you very much. Okay, anyway, thank you very much. We are now ready for our last presentation in this session. And I think Dr. Nabil is ready for his presentation on the paper entitled a novel model for chart-to-text generation by utilizing neural net models. Dr. Nabil, you have the floor, please.
Thanks, Dr. Ornardo. Mr. Hamad Malik is going to do the presentation.
Okay. Go ahead, Mr. Mohammed. Is he here, doctor?
Yes, he is here. Mr. Hamad Malik.
Hamad. I thought Mohammed. Okay, Hamad. Go ahead, Hamad. The floor is yours. You can just unmute yourself, Hamad, and share your screen.
Hi, Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Hamad Munir, and today I'll be presenting our research on a novel model for image captioning model to convert to captions. Let me share my screen. I think there's an issue. Okay. So I hope that people can see the screen. Let's start. Okay. So today we'll be discussing a new method to convert chart to text by using NN models, neural network models. So today's outline is introduction, and then we have literature review, methods and procedures used, results and discussion, and finally the conclusion. Let's start with the introduction. So this is our problem. We have scientific figures. Usually we call them figures. We have figures like bar chart, pie charts. We have figures like these. And we have figures like these. Okay. And we'll make a model which will create these figures and give us captions. Okay. Why do we need such models, or why there was a need for this technology? So that we can have clear communication in science, we can improve the readability and accessibility, and finally, we can support a non-expert audience. Challenges that are being faced in this field is the complexity of the content. Sometimes we have very complex charts, contextual relevance. If we just give you a figure, you don't know what's the background, why, what's the points being compared, and diversity in the chart types. We have many types of charts, pie chart, histograms, many types of charts. Okay, so here's the research problem. The research problem is to automatically generate accurate and contextual relevant textual description for scientific charts. The objectives that we have, the first objective is to design and implement a hybrid neural network model combining CNN model and RNN model. The second objective is to compare the different type of RNNs. The name are LSTM, BiLSTM, and GRU to see which one gives us the most accurate score. Thirdly, we'll be fine-tuning the models by using different parameters and looking for which one gives us the best B and EU score. We'll be discussing what this score is. Okay, why was this research needed? First of all, there's a very good, very comprehensive research done on this topic, which is SkiCap. So we'll be building on that foundational work. Second, we are bringing a new approach to chart to text, which was not seen till now. And finally, we'll be combining and optimizing CNNs. Okay. Okay, so let's shortly discuss the scope of this research and the limitations. The scope is to build upon this keycap data set. Okay, we'll be just focusing on this data set. The types of data, which are graphs, charts, and plot images. Note different type of images, and the models will be CNN and RNNs. CNN for image extraction and RNNs for text generation. Limitations, or you can say the boundaries of this research, is that we'll be focusing only on the scientific charts, not on different types of charts like medical or some stocks or finance charts. And of course, we are limited in the computational resources, so we cannot train tens and thousands of images at the same time. Okay, so in this thesis, we are tackling three questions. The first question is, how can neural network models be effectively integrated and automate textual description for scientific charts? Secondly, does this choice of using different types of RNNs and comparing which one gives the best, is this a good choice? And thirdly, did we actually overachieve the ski cap in terms of accuracy and in terms of scalability? Let's discuss a little bit about literature review. The previous research, as mentioned, ski cap, it was a research in which they combined scientific figures from more than 290,000 research papers. And there were two parts of this research. First one was to collect all of these data, pre-process them, remove, clean the data. And the second part of this research was to create a basic baseline model in which they can generate captions. So we'll be working on the same data. We will just take the data from that research, and no need for pre-processing, collection, cleaning, nothing. We'll be just creating more models, more high models, and trying to see if we can achieve better results. A justification why we needed this research. In conclusion is we have many models that are converting images to text, but scientific charts to text, we don't have many researchers in this field, especially since we have neural networks. Many researches were done, but they were using statistical models, mathematical models, but very less researchers are using neural networks, deep learning models. The methods and procedures which we followed in this research. First of all, the data set. We have a data set of multiple charts. They can be divided into pie charts, line graphs, scatter plots, and each of the chart will have a caption, and we will be dividing them into training and validating model data sets. The source of this data, as mentioned, there is 290,000 papers from which the images were collected, and these papers are from RZIP. Pre-processing, we will be converting all of these images to 256 by 256 pixels so that we can form uniformity, and also it can be feed it into the CNN models. Finally, word embedding. The captions, they are tokenized so that it can be entered into the. They can be it is pre-processed so that it can be used in the models. Training. As you can see, here's a small chart. Basically, we have data collection, image pre-processing, text pre-processing. This is done. This is before feeding the data. Then we'll feed the data into these models, BestNet, LSTM, GRU. We'll be training the data, the model basically, and then we'll be getting scores, and we'll be comparing the scores. We'll get BLEU4 scores, and we'll be comparing them. The models used CNNs, RNNs, and here's the new thing, performance metric. We are using BLEU for performance metric. Basically, it's standard used in English language models. so that they can compare different models with different models and see which one gives the most accurate English line or sentence. Okay, so here's a graphical visualization. Initially we have a scientific graph. We'll feed this graph into ResNet 101, which is a type of CNN model with multiple layers. And then from this model, we'll get some image vectors. We'll feed them first into LSTM and then again in ST. We'll be running 3 tests, one with LSTM and getting the text output, one with GRU and then text output, and one with by LSTM. And finally, we'll be comparing the output from LSTM, GRU, and by LSTM and looking which one gives us the best BLEU score. For BLEU, 0 is the worst and 1 is the best. Okay. In our research, we looked into CNN models, and the 2 best which worked in chart to text or image to text were ResNet 101 and Inception V3. After comparing them, we went to select ResNet for our research. The RNNs, we use 3 types of most common used RNNs: LSTM, long short-term memory, GRU, and by directional long short-term memory. Again, the score, why we selected BLEU. First of all, it was used by SkiCat. And since we are building on that research, we also use the same score. Also, it is standard in this field. Whenever we have models that create caption or that create text, we usually use BLEU 3 or BLEU 4 or even BLEU 2. And it is quantitative. We can see the results in numbers so that we can compare, and it's reproducible. It will give the same result. If we feed the same data, it will give us the same result. Okay. The results that we got, here's a data set, the number of figures. Overall, they were around 2 million, less than 2 million figures. Here's the number of total figures, graph plots, how many were there, tables, equations, and stuff like that. Here's an example. Figure looks like this, and this. We have some figures with multiple subfigures. Okay. So what we did was to make things simple, we ran multiple tests, and in those tests, we divided the data into 3 types: figures, normal figures, charts with figures, charts with subfigures, and charts with figures and with captions, big captions, small captions, captions with, like here we can see, we have captions with only 1 sentence, single sentence captions, and captions with less than 100 words. And then we have a second division, which is yes, no, like does it have subfigures? Yes, no, yes, no, yes, no. So in total, for the same data set, we have now 3 categories before and 3 categories afterwards. So we have total 6 tests. Experimental setup, we split the data by 80, 10, 10, 80 for training, 10 for validation, 10 for testing, which is standard, and some of the decay factor and optimizer, which were mostly taken from SkiCat. And we set different batch type, different drop rates, and trying to see which one gives us the best results. Here are the hyperparameter set: number of layers 1, 5, 10, number of hidden units 128, 256, 512, and similarly for drop rate and learning rate. We tested the models many times with different values. Here are the findings. As we can see, we have LSTM 3 times, GRU by LSTM, learning rates, drop rates, batch sizes, and overall we can see for 1 sentence we got the highest BLEU score for by LSTM. Similarly, for single sentence captions, we got the highest BLEU score for by LSTM, and for caption with less than 100 words, we got the highest BLEU score for LSTM, and which was very nearly followed by by LSTM. So it is clear from the experiment that by LSTM performs best when we combine it with CNN model for chart to text problems. Here are the reason why Bias team performed the best and why the other models did not perform very good. Comparison with the previous study, here's where we can say that we did something good. You can see the blue is the previous study and the orange is our study. So in terms of first sentence and single sentence, we performed better than the previous study. And in terms of caption also, we performed a little bit better. The reason is because of BiLSTM. The previous study did not use BiLSTM and we did. Here is some of the outputs by which you can understand. So here we have a figure. Here we have the golden. Gold means the real caption. And here's the model output with which the model gives about this figure. We'll feed this picture to the model and it will give us this text. And then we'll compare this golden with the model output, and then we'll get a BLEU score, which is 0.23 for this case. Similarly, for this case, the model gave us some text, which is, we can say the model gave us false data and BLEU score was very less. Here, since the data is very complex and even a human can understand this graph, so the model gave us very low score. It was a 0 score, and it was it failed. The model failed to generate any informative data. Conclusion. Again, the goal was to build upon the work done by SKCAP. And what we did was we used ResNet 101 combined with LSTM, GRU, and BiLSTM. The approach was to combine them, and we focused by focusing on CNN, we extracted the details, features from chart images, and RNNs, we used them to turn these features to text. The finding was that BiLSTM performed the best, and it gave us a BLE score of around 0.3. So why this research was good and why the challenges which we achieved. One of the challenges is that still the technology has not evolved and it is very lacking in terms of when we compare it with human-like captions quality, but still it was one step up. Future work that can be done, we can use more advanced neural network architectures. Especially we can use transformer models, which are very common today, ChatGPT, and many of them are using them. Multi-model learning, we can combine visual data from figures. And also we can take text from the same papers so that we can get more accurate captions. And diverse datasets, we can use more datasets so that we can train the model more accurately. Thanks all for attending. Let's open the floor for Q&A.
Thank you very much, Hamad, for the presentation. Now we are ready for the Q&A. So anyone have any question? Any questions from the attendees? Yes, go ahead, Hassan.
Okay, thank you for your presentation, Mr. Hamad. I have a question. Have you tested the model with another data other than the one in the data self itself?
Yes, thank you. Actually, no, we did not test our model with different datasets. The reason is already this dataset is very comprehensive. It is very big. Secondly, you can say we had less time. So we only focused on this dataset. Our focus was more on models. That's why we did not compare it with different datasets.
Okay, thank you
very much.
I think there's a question from Mohanand. He was saying in the chat, which one is better, LSTM or by LSTM?
Definitely, from our research for chart to test, by LSTM performs better. Maybe the reason is it's coming from both directions. That's why.
Okay. So, any more questions? Well, I just have one very,
Sure.
very, come on. Well, if you are going to, for example, because we know that neural nets is an ongoing research and it's far from getting perfected. So all those researches that are ongoing under this area, yeah. For example, from your output, for example, if you're going to rate it from 1 to 100, okay, for example, how far are you with your result?
Yeah, of course, it is very low. It is like from 0 to 100, it's like 30% in terms of accurate output, basically.
All right, thank you. And we have another one. In what scenarios would using a bidirectional LSTM be more beneficial?
Again, why? What?
Yeah, it's a question from Ali Hassan.
Yes.
He said, in what scenarios would using a bidirectional LSTM be more beneficial?
Usually, when we go deep into the models, we see the what do you say? We see the the structure of a model. We can see that LSTM. The problem is it's with the global minimum, and sometimes it's overshoot the global minimum, so the accuracy drops. So for this, the researchers they brought by LSTM so that the global minimum can be shortened. So how this helps, it depends upon the problem. Sometimes LSTM is good, sometimes bi-LSTM is good. So in our case, we found out that bi-LSTM was good, maybe because there's and it's maybe there's lots of data. That's why it was good for us.
Thank you, Hamad. Any more questions? Because I think we have a lot of attendees. So anybody else from the audience have questions? You can just write them in the chat box if you have any. I just said thank you very much, Mr. Hamad. Okay, so anyway, I think that's it for today's session. So we would like to thank everyone who presented today, and we hope to see you again in our future conferences. And of course, thank you very much in behalf of our university. Thank you. This concludes our session. Thank you, everyone.